this class, we are going to discuss about the full wave semi-converter with a RLE load. So, why we are going to call this converter as semi-converter means the circuit is consisting of two SCRs and two diodes. That's why we are calling as a semi-converter. The input is AC voltage, output is RLE load. We have taken the continuous current mode conduction. To analyze the circuit, we have taken the input voltage VAB and VBA. Let's take the T1 and D2 is conducting. The load is connected to source, so the load voltage is equal to VAB. Suppose if the T2 D1 is conducting, the load voltage is equal to VBA. SCR requires a triggering voltage, but diode does not require any triggering voltage. Whenever it is forward bias, it goes to the on state. Whenever it is reverse bias, it will be off. So we are applying only triggering voltage to the SCR1 and SCR2. SCR1 is apply the triggering voltage with a delay angle alpha and 2 pi plus alpha. Again we are applying the triggering voltage to the SCR1. For SCR2 we are applying the triggering voltage at pi plus alpha and 3 pi plus alpha. So when we are going to apply the triggering voltage to the SCR means whenever it is forward bias, then only we have to apply the triggering voltage. Now we are going to see the output voltage waveform. From 0 to pi, A is positive and B is negative. So the T1 is forward bias whereas the D2 is forward bias. The D2 directly goes to the on state. Till you apply the triggering voltage at T1, there is no closed path between the load and the supply. So at alpha, there is a closed path between the load and supply through the T1 and D2. So from this point, the load voltage is equal to VAB. After pi, the T1 is forced to conduct because of this inductance, whereas the input voltage becomes a changes. This is minus, A becomes a minus and B becomes a plus. So with this polarity D2 will be off and D1 will be forward bias. On the same leg, two devices are conducting T1 and D1. It's simply making a short across the load. Now the load current will be passing from load D1, T1, again load. In this interval, the voltage across the load becomes a 0 up to pi plus alpha. At pi plus alpha, we are applying the triggering voltage to the T2, so the T1 will be off and T2 will be on. Once the T2 is on, again the load is connected to the source through the T2 and T1. Now the output voltage becomes a VBA from pi plus alpha to 2 pi. After 2 pi what happened means, again the input voltage is reversed. This is plus, this is minus. So with this polarity, the D1 will be off, whereas the D2 will be conducting because it is forward bias. On the same leg, again T2, D2 is conducting. Now the load current will be passing from load and T2, D2 in this manner. So again the output voltage will be 0. The same circuit operation. Pi to pi plus alpha, freewheeling action will be taken place through the T1, D1. 2 pi to 2 pi plus alpha, again the freewheeling action will be taken place T2, D2. In a semi-converter, even though if you are not keeping any freewheeling diode, there is a freewheeling action taken place within the circuit. Here we have taken the continuous load current. So the current will be increased to the maximum value and the current will be decreases to the minimum value when the load voltage is 0. This manner. Now we are going to draw the source current. From alpha to pi, the T1 D1 is conducting. So the source current is equal to load current, that is positive. So what is the waveform is there from alpha to pi, you take up the same waveform here. Freewheeling action taken place means source is not supplying any current, so 0. Again from this point to this point, source is supplying current through the T2 and D1. Again freewheeling action 0. Complete the waveform. Now we are going to find out the average output voltage. 0 to pi, what is the waveform is there? The same waveform. So the base length becomes a pi. 1 by pi integral alpha to pi Vm sin omega t d omega t. If we complete this integration, we are getting the V0 equal to Vm by pi into 1 plus cos alpha. Now we are going to keep the same circuit operation in the table form. Alpha to pi T1 D2 is conducting. Output voltage becomes a VAB. Pi to pi plus alpha on the same leg 2 devices are conducting. T1 D1. The output voltage 0. Pi plus alpha to 2 pi T2 D1 is conducting. The output voltage VBA. 2 pi to 2 pi plus alpha T2 DT is conducting on same leg again 2 devices are conducting. The output voltage becomes a 0 here. Freewheeling action. Variation of output voltage versus firing angle. Take the firing angle on the x-axis, voltage on the y-axis. Here we have taken the three instants 0 degree, 90 degree and 180 degree. At 0 degree we are getting the 2 Vm by pi. 90 degrees we are getting the Vm by pi. 180 degrees of firing angle we are getting the 0. If we combine these 3 points we are getting the variation of output voltage versus firing angle. From this we can say that single phase semi converter for the continuous load current it gives only the one quadrant operation. Nothing but a we can operate the RLE load as a motor only. We can't apply any braking. Thank you very much for watching this video.